Okay, in this video we're going to go through several examples of being dealt cards from a standard deck of cards. So just as a reminder, when you have a standard deck of cards, that's 52 total cards. There are 4 suits within that deck. You have the spades, the clubs, the hearts, and the diamonds. And then within each suit, there are 13 cards, and they're labeled ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king. Okay, so let's start with a slightly simpler problem of just selecting one card from that deck, and then we'll build up to selecting a poker hand, right, which is when you're dealt 5 cards. Okay, so starting with this first example, when you are just selecting one card, the probability of randomly selecting a heart. Okay, so what is the probability of randomly selecting a heart? So I'll do probability of H, where H is the event of selecting a heart, right? So in the numerator, we want to think of, well, how many hearts are there in a deck of cards? In a deck of cards, you have 13 hearts, right? The ace, 2, 3, 4, 5, all the way to king. You have them all as a heart. You have all these cards within each suit, right? So you have 13 total possible hearts out of 52 total cards, right? So in the numerator, when you're trying to calculate a probability like this, you try to think of the number of possible ways you can get our interest, right? And then in the denominator, you have the total possible outcomes, right? The total number of possible outcomes. Okay, so total number of ways you can get whatever our interest is based off of, which event you're trying to calculate, and then the denominator, the total number of possible outcomes. So since we're only selecting one card, you have only 52 possible outcomes in that deck. Okay, of course, 13 over 52 can be simplified into 1/4, which also makes sense because there are 4 suits and they each have 13 cards in each suit. So you know that you basically have a 1 out of 4 chance of getting one of these 4 suits when you randomly select a card. Okay, all right. Now making the problem slightly more difficult. What's the probability of being dealt a flush of hearts? So a flush of hearts is when you have 5 out of 5 cards when you're being dealt a hand in poker, and all 5 of them are hearts. All right. So a flush of hearts. What is that probability? All right. So same thing in the numerator. We want to count the total number of ways that we can get a flush of hearts. All right. So remember, there are 13 hearts in the deck. You have the ace, 2, 3, 4, jack, queen, king. There are 13 hearts in the deck, right? They're labeled, these guys. And we are basically, in order to get a flush of hearts, you need to randomly select 5 of them, right? So you have 13 hearts, and you need to choose 5. So that's making us think, do we need to use a combination or a permutation perhaps to count the number of ways that we can have 13 cards and choose 5? All right, so which one is it? Is it going to be a permutation or a combination? Well, remember, permutation, order matters, or position matters. And in combinations, you have those crazy combinations where order does not matter. So when you are dealt a hand of cards, does order matter? Okay. In other words, if I'm dealt an ace of heart, a 3 of heart, a 4 of heart, a jack of heart, a 2 of heart, okay, is that the same thing as being dealt a ace, 3, jack, 2? Yes, of course. These are identical hands, right? In a hand of cards, the order that you were dealt those cards does not matter. So that's why we know we're going to be using a combination. You have 13 hearts and you are choosing 5 of them, right? And that's how you will count the total number of ways that you can arrive at our interest of getting a flush of hearts. Okay, now what's the total number of possible outcomes? If you have 52 cards, you need to choose 5 of those 52 cards. All right, so now, how do I solve this? How do I figure out what this equals? Well, I could just go straight to a calculator, and that is what I'm going to do. Of course, you can also use the formula and choose k equals n factorial over k factorial, n minus k factorial, and then you'd have to do that both for the numerator and denominator, and of course that will take you some time. So how would you do this on a calculator? Most of us have Excel on our computer, so the quickest way to do this is just to use Excel. So if you type equals combine, that is the combination formula in Excel. So we want 13, choose 5, divided by combine 52, choose 5, close parenthesis. All right, once you have that written out, then just press enter and you get 0.0005. Okay, so 3 zeros and a 5. Pretty unlikely probability of getting a flush of hearts. All right, what is the probability of being dealt a flush? So that means that you have 5 out of 5 cards that are the same suit. It doesn't necessarily need to be hearts. All right, so first thing you need to do is choose which suit you have. Now this is kind of like a multiplication rule type problem. You have part 1, right? Part 1 where you are choosing your suit. And then you multiply that by part 2 where you're choosing the 5 cards from that suit. Okay? So choose the suit, choose the 5 cards from the suit, and then divide that by the 52, choose 5. Okay? All right, and then once again, we could use Excel to solve this and figure out what this equals. I can actually just double click here and do 4. Well, I know combine 4 choose 1 is just going to be 4, but let's go ahead and write it out. So combine 4 choose 1. I accidentally did a period. Let's erase that and make that a comma. All right, and then multiply that. All right, there you go. Press enter, and you get 0.00, I can round that to 2, 0.002. Okay, so it is much more likely, however still unlikely, that you will be dealt a flush. Remember, if you were to change this into a percentage, you move the decimal over twice, so this is 0.2%. Okay. All right, what's the probability of being dealt 3 kings and 2 queens? Right, this is a very particular type of, was it full house? Right, full house means that you have 3 of something and 2 of something else. Right, so I'm going to go ahead and just do the 3 kings and 2 queens. This is a particular type of full house. So the probability of 3 kings and 2 queens, all right, in the numerator, total number of ways I can get my possible outcome of interest. So this is similar, this is a multiplication rule type part, where I have two parts. Part 1 is going to be getting that king. All right, how many kings are there? There are 4 kings in your deck, and you need 3 of them. All right, then multiply that by part 2, which is getting that queen. There are 4 queens in your deck, and you need 2 of them. All right, and then we still have those 52 cards, and we are choosing 5. All right, so once you're here, go ahead and go to your calculator and figure out what this equals. So equals, I'm going to use parentheses to keep my numerator together. Combine 4 choose 3 times combine 4 choose 2, divide that by combine 52 choose 5. Oh, I need to close the parentheses for my numerator, so put that here. All right, once you have your formula, double check it, Okay, press enter, and you have this very small, this -0.06. That means to move the decimal over to the left 6 points. Okay, so that would be, let's see, what was it after that? 9. Yeah, so move it over 6 points, so I'd have 1, 2, 3, 4, 5, 9, right? Because that's 1, 2, 3, 4, 5, 6. Okay, so 5 zeros and then a 9. Very, very unlikely outcome of being dealt those 3 kings and 2 queens.